Hi, this is Mrs. Rodriguez with another lesson video. Today's lesson video is on adding fractions. So when fractions have a common, which means same, denominator, you can add them because the parts of the fractions are the same. So there's a couple of things I want to point out. First of all, you have to remember that the denominator is the bottom number of your fractions. So what we're saying is these numbers here have to be the same. So here is an example of fractions with common denominators. We have 3/8 plus 2/8. Now, what do we mean by the parts of the fraction are the same? Well, we can add them because as you can see with the 3/8 and the 2/8, that each of these sections, right? So each of these sections are equal because each rectangle has been divided into 8 parts. So that means that each section of the rectangle all equal 1/8. There's 8 sections altogether. Both rectangles have the same number of sections. So that means each section is 1/8. And notice, the rectangles are both the exact same size. So, exact same rectangles divided into 8 parts, so each part will be equal. Okay, and each part is equal, it's equal to 1/8. So we can go ahead and add them because if we have 3/8 on one side and 2/8 on the other, we can say we have 5/8. But when fractions have different denominators, you cannot add them because the parts of the fractions are not the same. So let's take a look at this example, 2/3 plus 4/5. On the left we have 2/3, on the right we have 4/5. So you'll notice both rectangles are still exactly the same size. However, now they've been divided differently. So on the left, 2/3 means that each of these is worth 1/3. And on the right, it's been divided into 5 parts, so that means each part is now worth 1/5. And you will notice that the parts are not equal. The 1/3 is much bigger than the 1/5. So we can't add them together because you would be adding 2 things to 4 things that are smaller. It doesn't make sense. And then it would be what? 6 out of what? Would it be 6 out of thirds? Would it be 6 out of fifths? Like it doesn't make sense because the parts are not the same size. Okay? The parts of the fraction are not the same size. So what do we do if fractions have the same denominators? Well, when there's the same, we can add them. But what do we do when they have different denominators? Well, different denominators, I'm going to show you 3 different ways you can still add them together. So the 3 ways are going to be the giant 1 method, the butterfly method, and to draw a diagram. So let's get started. So the first method, the giant 1 method, what you need to find is your least common multiple, okay? Your least common multiple. That means the smallest number that both 3 and 5 multiply into. And the way I like to do it is I draw my little table, okay? And multiples would be times 1, times 2, times 3, times 4, times 5. Okay, and we're going to do that for 3 and 5. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. Then we do it for 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 20, and 25. Now the goal of this is we have a list of multiples for both numbers and we're looking for a matching number for both. So do they have any numbers in common or that are the same? Remember, common means the same. And they do. We have 15 here and 15 here. So that means our least common multiple, our LCM, equals 15. And you might be thinking, well, why is that a big deal? That's a big deal because your least common multiple is going to be your denominator. So that means the denominator is going to be 15. Okay, so you want to find the least common multiple because that ends up being the denominator you need for both of these fractions in order to add them together. Now, some of you might have looked at 3 and 5 and said, okay, a number that they both multiply into 15, right? You might have been able to do it in your head. So remember, I'm showing you how to do this with the table so that if you get numbers you're not sure about, you know how to still figure out what your least common multiple is supposed to be. Now, if 5 spaces, if 5 multiples was not enough for my chart and I needed more, then I would have just added it on. Okay, so try the first 5 multiples for whatever numbers you're working with, and if it's enough, great. If it's not, you can always add on to the table. All right, so now we know that 15 is supposed to be our denominator for these two fractions. So I'm going to go ahead and take these two fractions, 2/3 and 4/5, and now I know that I need to multiply both by a giant 1 that gives me 15 as the denominator. Okay, so we found the least common multiple. That tells us what denominator we're supposed to have. So now I need to multiply by a giant 1 to convert these fractions. Now, why do we call them a giant 1? We call them a giant 1 because these fractions, whatever fractions that we come up with, or whatever numbers we come up with, so for instance, in the first case, 3 times what number gave us 15? 3 times 5. Okay, well, if 5's the denominator, we call this the giant 1 because whatever you multiply on the bottom, you do the same on the top. And 5 divided by 5 is 1. And if you'll recall, 1 times any number is the number. So by making our giant 1, 5 divided by 5, it actually just equals 1, right? Because 5 divided by 5 is 1, and 1 times 2/3 is 2/3. We didn't change anything. That's why we want to multiply by our giant 1, because we want these fractions to be equivalent fractions. We don't want to change the fraction value. We just want to change the fractions so that they can have a common denominator, but we're looking for equivalent fractions. And if you don't remember what equivalent fractions are, please watch the video on equivalent fractions. So we're using giant 1s because they equal 1 and they don't change our fractions, they just give us equivalent fractions. So now I look at 4/5 and I go, okay, what times 5 gave me the 15? It was 5 times 3 that gave me the 15. So whatever's on the bottom has to go on the top because it must equal 1. So 3 divided by 3 equals 1. And 4 times 3 is now 12. 2 times 5 is 10. So now we've successfully converted our fractions using the giant 1 to get equivalent fractions, meaning fractions that are equal. Okay, 10/15 is equal to 2/3. 12/15 is equal to 4/5. Okay, 2/3 and 4/5 are just the simplified versions of these two fractions. So now that we have our two equivalent fractions and they both have a common denominator, we can go ahead and add them together. Okay, 10 plus 12 is 22 over 15. And I can simplify that by thinking, well, how many times, this is an improper fraction, 22 is larger than 15, so I can think to myself, how many times does 15 go into 22? It goes in once. What's my remainder? Well, 22 minus 15 is 7, so my remainder is 7, and the denominator stays 15, and I get 1 7/15. Okay? So that's the giant 1 method. Your goal is to convert or change the fractions by multiplying by a giant 1 to make equivalent fractions that will now have a common denominator so you can add them together, okay? And the fractions now have the same parts, right? 1/15 and 1/15 are equal. So if we have 10/15 on one side and 12/15 on the other, we can add them together. All right, let's take a look at the second method. The second method is called the butterfly method. Now, this method is different. The butterfly method is when you multiply the numbers across from each other, and then you add them together, and you multiply the two numbers on the bottom for your denominator. So what does that look like? I'll go ahead and use the specific numbers for the different part, or a specific color for the different parts so you can see where I'm getting them. So 5 times 2, oops, 5 times 2, and that would be plus 3 times 4 all over 3 times 5. Okay, now we go ahead and multiply everything, right? Take care of our parentheses, and we get 10 plus 12 over 15. Okay, now we go ahead and add our numerators, the top numbers, and we get 22 out of 15. And once again, we simplify, and it ends up equaling 1 7/15. So that's another thing you could do. Instead of worrying about trying to find a common or at least common multiple and trying to find a common denominator and making the chart, you can just use the butterfly method, cross multiply, add the two products together on the top, and it will be all over the multiplying the two denominators. Clean it up by simplifying your parentheses, and there you go. That's the butterfly method. All right, last but not least, we could draw a diagram. 2/3 and 4/5. Just like we saw in the original problem, I have identical rectangles. The first one's been divided into thirds, and the second one's been divided into fifths. Now, when you do the diagram method, the goal is to keep dividing the rectangles until you have the same number of parts in both. So right now we have 3 parts in the first rectangle and we have 5 parts in the second rectangle. So we're going to keep dividing both rectangles until they have the same number of parts. Now, 3 is less than 5, so we're going to go ahead and we are going to divide 2/3 and see what we get. Oopsie, straighten that out. Okay, so now we have 1, 2, 3, 4, 5, 6 parts in our first rectangle. Well, 6 parts is bigger than 5 parts, so now we know we have to divide our second rectangle, because remember, the goal is to make them even. So here we go, or the same number. So now I count the parts on the right-hand side, and now we have 10. Well, 10's bigger than 6, definitely not equal to 6, so we got to keep dividing. 6 is less than 10, so I'm going to go ahead and divide my rectangle on the left again. Let me go ahead and space these out so they look a little more equal. Okay. So now I count the parts on the left, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is still less than 10, so that means that I have to go ahead and divide the left-hand side again, because it's still less than. So we're going to keep dividing until they're equal. Oops. Let me go ahead and space these out. All right, so now I have 12 on the left-hand side and only 10 on the right-hand side. So that means now we're going to have to divide the right triangle because it has less than the left. So I go ahead and I divide it up. Let me move these so they look more evenly divided. Okay, now I have 15 on the right, but I only have 12 on the left. So that means I have to divide the left again because it's less than the right rectangle. So I'm going to go ahead and move these over. And I'm going to divide again on the left. Okay, so now I count how many parts I have on the left-hand side rectangle, and now I have 15. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. On the right-hand side, same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That means both rectangles have the same number of parts now and they're equal. The rectangle on the left, the parts might look different than the ones on the right, but that's because they're more stretched out and longer, right? Because we divided it differently than we did the 4/5, and the 4/5 is more square looking. But they both have the same number of parts, both rectangles are exactly the same size, so that means each part is equal. And because each part is equal, now we know that one part on the left is equal to one part on the right. So the left-hand side now is no longer 2/3. It is now equal to 10 out of 15. And the one on the right is no longer 4/5. It is now 12 out of 15. So we can go ahead and add these together. And 12 plus 10 is 22 out of 15, which would equal 1 7/15. We could also draw that out. We could divide up a rectangle into 15 parts. One, 2, 3, 4, 5, and then 1, 2, 3. This is just a quick sketch. Okay, now I'm going to move my rectangle so it's more evenly distributed. Okay, so another thing we could do is, if you want to see it on the rectangle, is we had 10 out of 15 on the first one, so I can go ahead and color in, oops. I can go ahead and color in 10 out of the first one, so that's going to be 2 rows there. Okay, coloring in my 2 rows. And then 12 on the second one. Well, I only have 10 left, so that's going to fill in the rest of this rectangle, right? And then we're going to have another rectangle. Actually, let me go ahead and erase. Okay, I'm going to go ahead and make a copy of this just in case we need it. And I'm going to go ahead and we can start coloring in our parts of the fraction, or our parts of the rectangle. So here we go. The first rectangle now has 10 colored in parts. It's 10 out of 15. So that means I'm going to go ahead and I'm going to color in 10 parts or out of this rectangle. The second one had 12, so I have to color in 12 more. Well, as you can see, I only have 5. 12 minus 5 is 7, so it's a good thing I made a copy of that rectangle because I'm going to have to go ahead and color in 7 more. So there's 5, and here's 6 and 7. So, as you can see, even in the diagram, here's my 1 hole, and here's my 7 out of 15. So, there you go, the diagram method. You could draw a picture or a diagram, split up your rectangles, make sure the rectangles are the same size. You keep dividing them until you have the same number of parts in both, and then create your new rectangles, or just go ahead and add from there. As you can see, we keep dividing the rectangles until we end up with the common denominator, which is the 15 that we discovered in the first example. Okay, so there's the diagram method, the butterfly method, and the giant 1 method using finding the least common multiple and the giant 1. And as always, if you have any questions or need additional assistance, feel free to make an appointment with me for office hours. And don't forget, it's my job to teach you different tools to solve these problems, but it's your job to choose what tool you want to use.